What if, right now, you could see into your future? That'd be pretty cool, right? You could always have the right prediction on different game outcomes, always win at trivia night, or maybe even avoid death. For example, let's say your crazy grandmama was chasing you in a big bus, and you have 5 seconds to look into your future, see that future, and avoid the future where you die. Sounds pretty good, right? Heck, you'd probably become the president's go-to man for decision making. That is, if you didn't rid the world of all rulers and crown yourself future king. But what does the power of foresight even mean? Is it like Doctor Strange, who is able to look into all different realities and see the future that way? Or is it more like Yoda, who was able to get a vague sense of how Order 66 was going to happen? Or is it more like Dune's Paul Atreides, who kind of gets these visions but doesn't really know when they're going to happen? But here's the thing, those abilities are very complex, and those abilities are also way too powerful, so much so that if they were to be here on Earth as is, they would completely redefine physics as we know it. Everyone who majored in any sort of physics, their career's over, because physics would have to be rewritten completely. Oh, and that would just be if you could see into the future and predict the future correctly, not to look into all different realities like Mr. Strange here. I think in order to start with the basics of seeing the future, we're gonna have to set some ground rules here. First, are we talking about seeing physically into the future, or seeing kind of like a glimpse of the future? Because seeing a glimpse of the future doesn't mean you're seeing the future. You're seeing a reality of what the future could be.
To view alternate futures, to see all the possible outcomes of the coming conflict.
How many did you see?
14,605,000.
Which on its surface, there is no possible way you would be able to predict out of all of those possibilities of the future, which one is going to be the correct future. In order to see the future and know what is going to happen in the future, you would need to physically see the future, which at the moment would require a degree in astronomy and quantum physics, and honestly, it'd be way too complex for today's scientists to ever even hope to figure out. See, the first thing you'd probably have to do is figure out how to reliably bend space-time onto itself, creating a wormhole. Many have theorized that black holes are these actual wormholes, and that we have black holes all wrong. But as the great Neil deGrasse Tyson puts it, if you were to jump feet first down into a wormhole, at first you would feel this really good stretching feeling, like you're really stretching your body out. But then slowly you'd start to rip yourself apart, and you would become two halves of your former self. And then if you survived that, your top half would slowly rip apart, and so on and so forth, until eventually you're just a stream of particles flowing through this black hole. So assuming you live through all of that, welcome to the other side, which is likely just cold, black, dark space. See, this still assumes that the black hole theory is even 1% reliable, which it isn't. But even if it wasn't a black hole you went through, instead if it was a wormhole, your wormhole likely wasn't calibrated to end up in the right space and time in the future. See, maybe the wormhole does answer going to the future, but the problem is we still live in a universe that is huge beyond measure. And so in order to end up on Earth in the future, you'd have to reliably know where Earth is going to be in the future.
How much does the Earth cost? I'm gonna buy the entire Earth and be king.
But since we're assuming a genius level of IQ for your future seeing powers, let's go ahead and walk our future selves through it. See, now you're obviously probably thinking, we don't need to go to the future, that's time travel. We just need to see the future, which for the first time in this whole example, you have something working for you. The speed of light. Isn't that a wonder? Wrong. The speed of light is fast, but peering through a wormhole might not be as simple as just walking up to the wormhole and looking through it. Assuming the wormhole is safe, sure, walk right up, and take a look. But okay, fine. Let's entertain that. What if you could just summon the wormhole right above your head so that you can look through it and see your future? Yikes. Well, unfortunately, wormholes are theorized to have an enormous gravitational pull. So even though you've never pulled a girlfriend in your pitiful life, congratulations, you would feel very pulled towards my friend, the wormhole. Oh, and actually so would most people near you. And since we started with a wormhole, the mass would increase so much so that it would likely collapse into a black hole. So now congratulations, we now have a black hole here on Earth. Now if that black hole was just the size of the tip of a needle, that black hole would weigh the same amount as the moon. No, it would weigh 5 times the weight of the moon, just in the tip of that little needle black hole. And we just created a black hole large enough for you to look through. Which, yes, 5 moons is only roughly 6% the weight of the entire Earth. But the gravitational effect that black hole has on the Earth would create tidal waves astronomically large. Literally astronomically large. They would literally probably bend out into space, destroying all of Earth as we know it. Thanks, Phil. You just killed everyone on Earth. Now, is that the power that you want? I didn't think so. But back to the future. Okay, so now we're gonna have to leave this wormhole slash black hole far enough away from Earth so that it doesn't have an effect on Earth in case it collapses into a black hole. But now you have the problem of not being able to see into it. So let's add enhanced telescopic vision, or ETV, to your list of new powers that you have. So not only can you see into the future and make black holes slash wormholes, you now also get ETV. Great! Next step. As I said before, you would need to calibrate this wormhole to end up in the right space-time in the future. If we just pressed go on our new wormhole, you would likely end up seeing black utter space instead of your future. So we have to calibrate this to your future. And before any of you come after me with some odd science facts, come on, man, I'm dealing with hypotheticals here. To calculate where we are in space, we'd first need a map. Oh, and no, unfortunately our friend Map here is not gonna help us because even though he's 3-dimensional, his map isn't. We need a 3-dimensional map with an X, Y, and a Z coordinate. So the following are steps on how to calculate where the Earth will be in the future so that you could create a wormhole to see into that future. Let's program an wormhole. Because everything is spinning at once, our map needs to look like a corkscrew spiral helix. And the first and easiest thing to figure out, actually, is where the thing you are trying to look into the future will be. Is it you a year from now? Or is it a friend a year from now? What is it you're trying to see? To do this, we will have to look into the future. Wait, okay, that's actually what we're trying to do. So I guess we're just gonna have to guess on where you are in the future. So let's just say China, because that's where most people are. Okay, maybe not China. Let's pick somewhere better. Let's say the White House. In order to make this simple, let's just go 1 year into the future looking at the White House. But for other days, you're gonna end up having to be more precise than we are right now. So assuming we calculate the White House to be the so-called center of the universe, we will now put the White House at current 0, 0, 0. Oh, sorry, we just moved from 0, 0, 0 a second ago. Now we're further away from that. So now we're not on 0, 0, 0. You'll see why. If we travel with no gravitational effects for 1 year, where will we end up? Well, our solar system travels at a rate of 490,000 miles per hour. And if we assumed the positioning of our solar system would be on the z-axis, then our coordinates in a year would be 0, 0,
4.292 billion
miles away from where 0, 0, 0 is. Now, as I said before, we are not at 0, 0, 0 anymore. In the time it took me to say all that, we are more likely at 002974. But let's just forget about all of the movement. Let's just say that happened in 0 time. Now, we've accounted for where our solar system relative to the universe will be a year from now. And we've also accounted to where the Earth will be relative to our solar system a year from now, because the Earth will just loop back around and end up practically in the same spot. But this unfortunately doesn't account for any slight gravitational pulls in one direction or another that the Earth or the solar system might have, and so we might be off by a couple hundred or a couple thousand miles. So let's just forget about that as well. All of that is great. So now, assuming the solar system took a straight path through the galaxy, it wouldn't. Unfortunately, our galaxy is also moving through the universe at a rate of about 1.3 million miles per hour. That puts us another 11,388,000,000, roughly, miles away from our current positioning. If we assumed the galaxy would also travel in a relatively straightforward path, it wouldn't. Here would be our rough calculations of where Earth a year from now would likely be. Notice, these are the furthest we could be on each axis. On a map, this data would look more like somewhere in a big cube. Looking at this future destination using our ETV, this future destination would be about 23 hours and 24 minutes for the light from that area to hit your eyes. And we still need a wormhole there. So let's pretend inside this cube, one of those numbers is correct and we guessed it precisely. And let's also pretend that all of this traveling was never affected by any gravitational pulls or anything to make our math off in the slightest. On top of this, let's pretend you 100% got the corkscrew spiral helix positioning 100% correct. You would still need to place this wormhole at a safe distance from the Earth and our solar system. Ideally, in order for a wormhole to be safe, in case it collapses into a black hole, even with just the radius of 40 meters, you'd have to place this wormhole 2.5 times further than Pluto in order to be safe from Earth and any effects on our solar system. And that's the minimum. It would be a lot safer and a lot better and a lot less risky to place it closer to 13 times the distance from Pluto, or roughly 48.1 billion miles away, which with your EVT would be 71 hours and 52 minutes just to look at this wormhole, and that's one direction. Now, this is where I got stumped. The distance, how far we need to put our wormhole, is further away than the distance Earth will be in 1 year. Meaning, your wormhole, to see the future, is gonna have to be further away than Earth will be in the future. So, in order to see the Earth a year from now, so that you can see your future, first you would have to make a wormhole or sort through every single reality ever. Let's stick with the wormhole. Next, you'd have to assume the wormhole can be bent into future space-time. It likely can't. Next, you'd have to estimate the almost exact coordinates that the Earth will be at a year from now relative to the universe. And unfortunately, no, you will have to be very precise, unlike what I've been in this video. Fourth, you'd have to place the wormhole 4.81 billion miles away from current Earth, and also 4.81 billion miles away from future Earth, so that neither of them can collapse into black holes, causing devastation on either current Earth or future Earth. Then, activate your superpowers EVT to look through this at the speed of light. Of course, this would take you at least 142 hours just to see the other Earth. And depending on your rate of travel on Earth right now and future Earth's rate of travel, it would potentially take you closer to 175 hours. Then, if you located on a spinning, traveling Earth, you could see your potential future. That is one crazy superpower. Also pretty inconvenient. Oh, and if you wanted to look at the future less than 6 days from now, forget it. The light just won't travel to your eyes fast enough. Because again, you're still gonna have to have this wormhole 4.81 billion miles away from current Earth and 4.81 billion miles away from Earth 0 to 6 days from now, which the time it takes for your eyes to see the light that comes through that wormhole would take longer than just waiting till you get to the future. So if that bus that your grandma was chasing you with really was a reality, I'm sorry, you'd be dead. You just wouldn't have enough time in the future to tell your future self what your future is. I am Lincoln, and it's just hypothetical. Hey, thanks for sticking around for your future to listen to past version of me. Speaking of the past, is your past interesting to you at all? Me neither. Maybe we'll talk about it in the future.